So today we'll look at the application of calculus. Specifically how to sketch. So we're doing an example, the one that is fully detailed. Question says, for f of x is equal to 10 minus 3x squared plus 2x power 3. What do you do? 1, identify the critical points of f of x. 2, determine the interval on which f of x is increasing and decreasing. We classify the critical points as relative maxima, relative minima, or neither. For determine the intervals on which f of x is concave down and concave up. 5, determine the inflection point of f of x, if any. 6, sketch f of x. So this is the question that you want to answer. So given a function there, and then you must do all those stuffs there. So we go solution. So we'll be slow here so that you can understand. And then I give you an exercise. For the first part, to find the critical points of f of x, first find f prime of x and equate it to 0. So for x, and the values you find, the values of x that you find, substitute in f to find the corresponding y coordinates. To form the point. So let's do that. So I said you're going to be slow on this question. And this is what I meant. We first state what you're going to do, and then we do it. So every time they ask you to find a critical point, the first thing you do is to differentiate the function f. Then equate to 0 what you get. Why equating to 0? You want to solve for x values. Those x values substitute in the original function for you to get the corresponding y values so that you can make a full point. Remember, my point is x comma 1. So we now get the function f of x is equal to 10 minus 3x squared plus 2x to the power 3. Then differentiate the function. What is f prime of x? The derivative of 10 is 0. The derivative of negative 3x squared is negative 6x plus 6x squared. Like that. This derivative found, we now equate it to 0. So equate f of x to 0. Meaning I get negative 6x plus 6x squared and equate it to 0. Here we can factor out negative 6x. We will remain with 1 minus x equated to 0. And then this means that negative 6x is 0 or 1 minus x is 0. So here x is 0 or x is equal to positive 1. These x values are called critical numbers, not critical points. Okay, so these are critical numbers. Because on those numbers, nothing is happening. Remember, the first derivative, when you're looking at the tangent issue, we say the first derivative is the tangent equation. I mean, it's a gradient equation. When the gradient is 0, it means there's no change. There's no increasing or decreasing. So we now need to find the points. With the x values obtained, we take them in the original function. So point 1. Okay, point 1, we take 0 in the function. The original one, so we have 10 minus 3 0 squared plus 2 0 power 3, giving us 10. So what's the point? the point is now 0, 10. This is a critical point. Point 2, f of 1. So we have 10 minus 3 by 1 squared plus 2 by 1 power 3. This will be 10 minus 3 plus 2, giving us 10 minus 3, that's 7, plus 2, that's 9. So a point is 1, 9. This is a critical point. So we have found the 2 critical points. So we have answered question 1. What next? Determine the interval on which f is increasing and decreasing. So we'll do this in 2 ways. The first way is we'll use the first derivative to determine why the function is increasing and why the function is decreasing. So our derivative f of x is equal to negative 6x plus 6x squared. To determine where f is increasing and decreasing, use the critical numbers together with f prime of x to form a testing table. Where f prime of x is negative, f of x is decreasing. And where f prime of x is positive, f of x is increasing. Okay, so we have the first derivative there, that is f prime of x. We also have the critical numbers, x is equal to 0 and x is equal to 1. The numbers we found here, as someone is capturing. Okay, so these two values, we form a table. So we put 0 here, then we put 1 here, as if we are doing inequalities. We form a table on this table. We put the derivative here, f prime of x Remember, f prime of x is negative 6x plus 6x squared. And then before 0, we can pick -1. And then we can pick between 0 and 1, we can pick half. After 1, we can pick 2. And then substitute now in the derivative. So what is f prime of -1? So we are getting -6 by -1 plus 6 -1 squared. This is -6 times -1, we get 6. Plus -1 squared multiplied by 6, we get 6. 6 plus 6 is 12. Our interest is this 12 plus or minus? It is positive. Then we go to f prime of half. We have -6 multiplied by half plus 6 half squared. This is -3 plus 6 over 4. That is -3 plus, this is like 3 over 2. And of course, we know 3 over 2 is less than -3. So this is, is less than 3, making this to be negative. Then we pick 2, who have -6 by 2 plus 6 by 2 squared. So we're getting -12 plus 4 times 6, that's 24, giving us +12. Wow, we just wanted to check if it's plus or minus. Here we said where f prime is negative, then f is decreasing. So f of x is decreasing on on 0 to +1. You should never include the boundary numbers. And f of x is increasing on -∞, 0, union 1, +∞. Here where it's positive. Here where it's positive. This is how we answer question 2. Method 1. Or method 2. Or we find the second derivative of x and then test the critical numbers or maybe I'll mention this because we want to use it to classify, and then that's when I'll mention it as an alternative. For now, I want you to pick this, but I'll mention the second one as an alternative when you're doing the classification now. Do I have any questions?
So,
Mm-hmm.
when writing those things for at f of x is decreasing on Shanshan, is there like where you can use the boxed things, those brackets for boxed, like for, I don't know. Or you just have to use these 2 brackets. You can't use the other ones for boxed.
These.
Mm.
You should never use this. Because those mean include. So if we include 0, nothing will be happening there. The gradient will be 0. And so there's no decreasing, there's no increase. It's stationary. Part 3. Classify the critical points as relative maxima, relative minima, or neither. So now we do part 3. Part 3. To classify the critical points what do? Find the second derivative. Find the second derivative f prime prime of f. After that, substitute. So you substitute each critical number in f prime prime of x, and when f prime prime of x is less than 0, the critical point is called relative maximum. That is 1, 2. When f prime prime of x is greater than 0, the critical point is called relative minimum. Three, when f prime prime of x is equal to 0, the critical point is neither relative maxima nor minima. So now let's classify. So the f prime of x was negative 6x plus 6x squared. So to find the second derivative, you differentiate the first derivative. So you differentiate f prime prime of x now becomes negative 6 plus 12x. Then remember the critical numbers we got where x is equal to 0 and x is equal to 1. So we substitute f prime prime of 0 is going to be negative 6 plus 12 multiplied by 0, giving us negative 6. This is less than 0. What does it mean? Implying that the point the critical point 0, What point did we get using 0? We got 0, 10. 0, 10 is relative maximum. Second, f prime prime of 1, that is -6 plus 12 multiplied by 1, giving us +6 greater than 0, implying that the critical point 1,9 is relative minima. Like that. What have we done? We've answered 2, we've answered 3. We're now going to 4. Determine the intervals on which f of x is concave down and concave up. So what do we do? We're saying that to determine the interval where f of x is concave up and concave down, equate the second derivative to 0 and so for x. So we have, what was our second derivative? Our second derivative was -6 plus 12x. So we have -6 plus 12x. So equate this to 0. Equate this to 0. Of -6 plus 12x is equal to 0, meaning 12x is equal to 6. Divide by 12. So we'll get x is equal to 1/2. Then form a table 1/2. So you pick a number less than 1/2, say 0. Or you pick a number bigger than 1/2, say 1. These numbers, you are testing the second derivative, f prime prime of x. You want to check the sign. So at 0, so you're saying f prime prime of x at 0, this will be -6. So it's negative. At 1, this will be +6. So you're putting 6 here. So it's plus. So what we want, where it's plus. Okay, so here let me use different numbers because it will look as though we use the critical numbers. Let me pick -10. I also want to pick +10. This side. So if I take -10 there, if I take -10, I will have -6 plus 12 by -10, which is less than 0. I also have -6. If I use +10, -6 plus 12 by 10, which is positive. So where f prime prime is negative, so f of x is concave down on -infinity up to +half. So where it's negative, then the function is concave down. And concave up on half to +infinity. Like that. Part 5. Well, since f of since f prime prime of x is not 0 on all critical numbers, there is no point of reflection. The last one is we sketch. Part 5, we sketch. The critical points are called turning points. So just pick them as they are. We have 0, 10, 0, 10. We also have 1, 9, 1, 9. And we said 0, 10 is relative maxima. So for it to be maxima, this is what we had. And then the other one is relative minima. This is what we have. So concave down, concave up. So observing there, concave down, concave up. So you could find this critical. You can find that turning point, I mean this intercept here, if it's easy, by doing the normal thing, the usual, equating the whole function f to 0. That is if it's important. Find the x-intercept. Okay, we have less than a minute. So the exercise, do one full question. From sheet, this is sheet 10. Question 15. And please make sure that you submit before you sleep. This is very, very important. Okay.
So I didn't see the number.
I just said any question from question 15. Question 10.
sir.
Uh,
I'm asking for the previous.